Alright, so there's really everything that we went over Friday is the same, except there's one exception. There's one special case that we have to look out for, and it only happens, the only time we have to worry about it is when we're talking about variables underneath a radical, okay? And so that's what we're gonna talk about today, that exception and what you have to look out for and then what you have to do. There's only one little thing, so what you've been doing is pretty much gonna stay the same. We just have to watch out for this one case. So this case is, again, it's for variables under radicals. When you have an even root.
Can we take a picture of that?
No. Please write it.
I can't see it. It's like on the block.
Okay, another word for root is index. So if you want to write that as an index instead of root, that's okay.
Is that like the... Why?
So the little number, the index is even, and the variable power underneath the radical is even, and your answer gives you an odd power. You have to put an absolute value around it. Okay, and I'll explain why when we go through an example. We're going to go through a couple examples and I'll explain why we have to do that. But what we're looking for is you got to watch out for this even, odd. Okay, even root, variable to an even power, result is an odd power. That's the only case we have to worry about, is when that index or that root is even, the power on the variable is even, and the power on the answer on the variable is odd. Even, odd. Okay, that's what we have to worry about. If it doesn't fall into that category, then you don't have to do anything different. But if it does fall into this category, we have to add an absolute value symbol, because we want to produce an answer that's non-negative. So the other part is, if you have an odd root or odd index, you don't have to worry about absolute value ever. If the root is even, then you got to worry about it. If it's odd, it doesn't matter. Let's talk about a situation, a simple one. I'm going to give you a real simple example, okay? If I take the square root of 16, right? We know what the answer is. What's the answer?
4.
4. You would never say the answer is negative 4, right? Whenever you take the square root of a number, you get a positive number. Okay? If we were in a situation where I was taking, let's try a tougher one, the fourth root. Actually, the fourth root is 16. Do you know what the fourth root of 16 is? What to the fourth power equals 16? You can try.
4 to the 16th.
What to the fourth equals 16? 2 to the fourth, is that right? Fourth root of 16?
Yeah, 2 to the 4th.
Okay. Now, the reason that we talk about these couple examples is, yes, I could raise negative 4 to the second power and get 16. I could raise negative 2 to the fourth power and get positive 16. But whenever we have a radical with an even index, these answers are called the principal root, and the principal root is always positive. Okay? However, if I look at something like the cube root of negative 27, okay, I can get a negative 3, because negative 3 to the third power is negative 27. So when the index or the root is odd, we can get negatives. When the index or the root is even, we can't get negatives. And that's what we're trying to prevent in this situation with the absolute value, okay? So let's look at a simple example first. All right, there's 2 examples up here, but we're going to work on the first one. So if you take the idea that we talked about on Friday for this first one, right? The fourth root of y to the fourth. Just shout out the answer. Y. Okay, y to the first. 4 divided by 4 is, right? The trick is, we don't know the value of y. Okay? Y could be positive, it could be negative, it could be 0, we have no idea. But because this is an even index, it's the fourth root, bless you, okay, it must give me a positive answer. Okay? And underneath here has to also be positive. And if I take a number and I raise it to an even power, if I square it, fourth power, sixth power, eighth power, if that number is negative to begin with, and I raise it to that even power, it will turn positive. Okay, so I have this even, then what's the power on y for my answer?
1.
1. So what I have is this even, odd. Okay? And what's interesting, and I'm going to show you how to do this with just a regular number. If y was a negative number to begin with, we would have a problem. Because you can't take an even index radical and produce a negative number. So what we do to combat that, okay, since this is even, odd, we put absolute value around the y to ensure that my answer is positive. We just don't know if y is negative or positive. So when I have this even, odd situation, the part that is affected by it, even index, even power inside, odd power is my answer, then we just put the absolute value around that answer part, and it only applies to variables to make sure that our answer could never be negative. Okay? So again, the even index, even power underneath, odd power as an answer. Even, odd. When that happens, we have to guard against it being negative. And the explanation is, since y could be negative, you have to put the absolute value around y. And this is what I talked about before about the principal root. Okay? Whenever I have an even index, the answer has to be positive. And so the reason why we don't do it for, let's say this was y to the second for my final answer. Okay? If I take any number and square it, the answer is positive. So I don't have to worry about it then. But if the answer is raised to an odd power and the number that represents the variable, what the variable represents, is negative, then it could still be a negative number, and we can't do that. We can't have that. Okay? So this is that one special case. Everything that you've done before is the same. But you just have to look out for this even, odd. So before you even get going on some of these problems, you want to look to see if you have an even. And if you have an even, then you got to watch out in case the power ends up being odd.
What's the odd? How do you know it's odd?
Odd is the power on the y in the answer.
Wait, so even's the 4, the other even's the 4, and then what's odd?
Here, I'll show you.
Okay. Can you like highlight or something?
I'm going to do that right now. So, this even is that one.
Yeah.
This even is that one. And this odd is that one. Even, odd. Let's look at B. First thing what I would do is it only applies to variables. So I'm going to separate these kind of into two problems. First, find the 6th root of 64. Do that like it's its own problem. Do that. 6th root of 64. The 6th root of 64 is 2. So the number part, you don't do any different than before. We're not worrying about even, odd or anything. It only is for that, for variables, okay? Now we look at the second part. Again, we treat this like it's just one thing, and in the other video, I highlighted it in red. One thing to the 18th power, okay? Here's the thing. I have an even index. This one thing is raised to an even power. So I have even right now. Now I need to be on guard. Because if the final answer for that part gives me an odd power, I'm going to need to have absolute value. Does it give me an odd power?
Yes.
What is it?
3.
3. So again, 18 divided by 6. So what I really have here, so far, I'm not done, is I have this one thing to the third power. So I have even index, even power, the answer is odd. Which means this whole thing could actually be negative. So what I do is I put all of it in its own set of absolute values.
You don't put the
I don't put the 2. The only part you put the absolute value around is the even, odd part. The 2's already positive anyway, there's no reason to. Okay, the reason we're putting those absolute values in is to guard against numbers being negative. And they're numbers, when I say numbers, we're really talking about variables, and we don't know what those numbers actually are. Okay? Now, one of the things that you guys may do, and I'm just gonna forewarn you, sometimes you're not sure where to put the absolute value, and you just start randomly putting them everywhere. And I know when you do that you don't know what you're doing, and I will take points off. So don't think I could just throw absolute values in there anywhere and I'm good to go. No, actually that tells me you really don't get it, and so I know that that's where I need to take some points off. This is the final answer. So if you don't have an even odd, I'll make up a quick little example. Let's say I have the okay, would you just wait, please? 4th root of y to the 8th. Okay. We have, in this case, we have even. Okay. When I find the 4th root of y to the 8th, what do I get? No, you don't get 2. Nope. You don't get 2, but you're warmer. Y to the 2nd, okay? So, what I have here is even. No problem. This is not even odd. We don't have to worry about absolute value. Done.
So we only worry about if it's even.
Even odd. That's the only time you have to worry about it.
Okay.
If the index starts out as odd, then it doesn't matter. If the even starts out at odd, it doesn't matter. If the power inside is odd, it doesn't matter. It only is when it's even odd.